What actually happens when a star of very high mass actually collapses under its own gravity when it is out of hydrogen? The thing which actually forms in these conditions we now know as black holes. They are actually the strangest things of the universe. If you would see at the boundary, you would see event horizon, that is at the boundary.
Event horizon actually is the boundary of the black hole. That is the only thing from which we can identify a black hole, and no other means is there by which we can identify a black hole.
Anything which will cross the event horizon should have a speed equal to the speed of light, but that is actually not possible. So we just see a simple disk inside which there is all the part black and we don't know what is inside it. We are not able to look inside it actually. But then what the rest of the black hole actually contains? It is actually singularity at the middle. Singularity is defined as a part where density is infinity and volume is zero. So this is just a mysterious part. Black holes, to the popular belief, are not immortals. They actually radiate heat by a process called Hawking radiation. In empty space, virtual particles come into existence and annihilate each other. But what happens when it happens at the event horizon? Actually, one particle could exit off the gravitational field and one could not, thereby decreasing the mass of black hole. As the mass decreases, the radiation of the black hole actually increases.
As now we have described black holes actually, we will now focus upon what are its applications on physics and what can we do.
One of the important applications of black holes is time travel. The crew members of a spaceship orbiting around a black hole would age half less than in compared to us. When they will return to Earth, they would actually be able to experience the future. Another important application of black holes is the idea of wormholes. Wormholes are hypothetical passages of space-time. If you would be imagining a ship just going through the singularity, you would be obtaining a picture like this. Since the singularity curves the space-time in such a high manner that it could even open pathways for a new dimension, just like this picture.
Now we will look towards the black hole in a particular sense. That what would happen if we would be approaching the black hole or even approaching the event horizon or even approaching the singularity. What would happen? Let us see.
The most important thing while going to the black hole is the slowing of time. You would be able to see the universe going fast forward in compared to you. Slowing of time in this case is the prediction of general relativity. Inside the event horizon, you could go only in one direction. It is like closing of gates at each level. Actually, you would die if you go inside the event horizon because of so much gravity. How much longer time you will live depends upon the size of the black hole. A smaller black hole would kill you even before you have crossed the event horizon. Whereas in the case of a larger black hole, you could travel to the center. As a matter of fact, the longer you are far from the singularity, the more you live. However, if by any particular means you reach to the singularity, you would be experiencing their wormholes. Since the singularity curves the space-time in such a high manner that there could be pathways for a new place through the space-time or the curved space-time. Stars are very high amount of hydrogen clouds. They actually support against their own gravity by a process called nuclear fusion in which they generate helium from hydrogen. As long as there is fusion going on inside a star, there will be no gravitational collapse. That is, the gravity and the radiation will maintain balance. But as the fusion process generates many other heavier elements such as iron, carbon, silicon, etc. Now as the iron grows more and more bigger at the core, the maintenance between the two forces actually collapses and the star also collapses, thereby creating all the bigger elements in the universe, forming two types of things, one neutron star and one black hole. As our journey started from a simple thought of collapse of a very high mass star under its own gravity, I have now explained that what is the structure and what does it form under such similar conditions. So now we have made to quit the biggest ghost of our universe, that we now know as the black hole.